Today we're going to be talking about solving linear quadratic systems by graphing. A system of equations consists of two or more equations, normally in more than one variable, used simultaneously or at the same time. Solutions to a system involve a point or points that satisfy all equations in the system, and we'll talk more about that in a minute. Solutions can be easily seen most of the time when the equations in a system are graphed on a single coordinate grid. Often the graphs of these equations will intersect. And in a system of two equations, which we're going to be talking about today, the points where the graphs meet are called the solutions, since the x and y values of these points make both equations true. In this lesson, we're going to focus mainly on linear quadratic systems where one equation is linear, its graph being a straight line, and one equation is quadratic, whose graph is a parabola. A system of this type may have one, two, or no real solutions according to how many intersection points there are. If the two graphs intersect at two distinct points, we have two real solutions. If they intersect at only one point, there's one real solution. And if they don't intersect at all, we of course have no real solutions. Let's take our first example. We have two equations, one quadratic and one linear. Let's first graph the quadratic function. We're going to use a graphing calculator to do that today. And then we're going to put the linear function on the same graph. You can see that the two graphs intersect at exactly one point, the point 0, -2. That makes the point 0, -2 our solution. It's our solution, and we can always check to make sure that's the correct solution by plugging our x value of 0 in for all the x's in our two equations and -2 in for the two y values in our two equations, and checking each equation separately to make sure that it's true. For instance, 2 times 0 in our linear function is 0, -2 would definitely equal the -2 of our y value. That's an easy way to make sure I have the correct solution, and we'll talk more about that in class. In example 2, our first equation is linear and our second is quadratic. Let's put the linear equation on a graph, then our quadratic function. And now you can see that these two functions intersect at two distinct points, the point 1, 3 and the point -2, -6. That means we have two real solutions and both points need to be listed. In example 3, again, we have a linear and a quadratic. Let's graph our linear function and our quadratic function. And this time you can see that they don't intersect at all. This is an example of when we would have no real solutions. In our final example, we already have one of our equations drawn. Our equation that makes up this circle is going to be in place of our quadratic function. We're also going to include the linear equation y equals 3/2 x plus 9. When we put that on our graph, having a y-intercept of 9 and a slope of 3/2, we can see that these two equations intersect at only one single point, the point -4, 3. So that's going to be our solution this time. That pretty much wraps it up since we are going to graph using the graphing calculators for this assignment. Make sure to write down any questions that you have and bring them to class. And I'll see you next time.